Hi everyone, this is the third video for the HEC-RAS model development. In this video, I will finish all the required development of the HEC-RAS model, including flow, path, and cross-sections. The flow paths are used to determine the downstream reach ranks along the left overbank, the main channel, and right overbank. Again, the flow paths are used to compute distances between cross-sections in the overbank areas. So let's create the flow paths. You need to move and check the flow paths and click flow paths again, and then you can start with the clicking the edit geometry. So the same method from the bank line, I will create from the left flow path first. So I can start from near in here. Just click further to digitize the flow path. Okay, so you need to consider you define the cross-sectional area with this flow path. Okay, so let's make like this one. So in here I will finish it double clicking the flow paths for the left overbank. So I created the first one for the flow path, and then I will make another flow path for this the right overbank area. So I start with this point and maybe I just end because I will make another flow path for the distributary areas. So also important thing would be to not cross existing flow paths for the overbank areas for the main channel. Okay, so I will create overbank the flow paths on here for the tributary. So maybe this would be sufficient. And then another one, I just created the tributary channels, the left flow paths, and then I will make the right overbank. So areas the flow paths like this one. So you need to consider another flow path for the main channel areas. So maybe this would be sufficient. So lastly, I would like to make another the lower part of the Wabash River's flow path. So I can start from this point and just develop the flow path. Considering some river cross section, just you can define your own flow path. So I all developed the required flow path from the left overbank for this Wabash River, and then right overbank first, and then I made the tributaries the flow path, and then lastly I made this right lower Wabash River's overbank. So this is the same orders from the last part 2 video for making this kind of the riverbank lines. So I all developed required the flow path and then go over the flow path and right click stop editing. And you can yes to save this developed flow path. So now we need to check the attribute table for the flow path. So click open attribute table. You can find this kind of created the flow path characteristics with count and length. Then you can close this attribute table. Now I will make cross sections for these rivers. Cross sections are one of the key inputs to HEC-RAS. And these are used to extract the elevation data from the terrain for creating a good profile across channel flow. The intersection of cross sections with the other last layers such as center line and flow path lines are used to compute HEC-RAS attributes such as bank stations, downstream reach lengths, and Manning's M. Therefore, it is critical to create adequate number of cross sections for producing a good representation of channel bed and floodplain. Also, some guidelines must be followed in creating cross sections. So cross sections should be start from left to right, like this direction, okay? And also this should be perpendicular with the direction of the flow, like this one. The same. And this cross section all cover these the flow paths, bank lines, and the center, river center lines, okay? So should cover this direction and also all these direction from the upper area to downstream area, okay? Be sure have some spacing for each cross sections, okay? And then I will create one bridge in here, so please consider when you are developing the cross section this the bridge area as well. So let's create cross sections. Very first thing you need to click this checkbox for cross sections and click cross section and right click to select edit geometry. And then this button is activated. You can find and then it is same way to click the starting point and then cover all the components required for this cross section and then double click. I made one cross section and another one. Please consider perpendicular with this flow lines, okay? And then another one, left to right. I will make only 5 cross section on here, okay? So I developed the upper Wabash River's cross section. And then I will develop another tributary things. So please consider all there. So you can zoom in here to see more clear the cross section to develop. 1, 2, should on here maybe I should one more thing in here, and then I will make with perpendicular again, like this one, then last one. So you can differently develop your own cross section for this HEC-RAS model development, but please consider the similar way to develop from again left to right and perpendicular with these flow lines, and all cover all these required the components. And then I will start from this point to make the lower part of Wabash River's cross section. So just one, another cross section on here. Maybe your work would be different from my one. When you are developing the cross section, please consider spacing as well. And also I will create the bridge again in here, so consider the up and down cross sections for these bridges. So this bridge location need two cross section near the up and down the bridges. So I will make considering these bridges to develop cross section. Okay, like this one, and then I would like to make 3 more cross section, 3 or 4 more cross section. Okay, I drew all the required cross section for this river system, for Wabasi River, and this tributary for the Tippecanoe River, and I considered this the bridge to create for the works. I think I all developed the required cross section. In that case, you need to go to cross section and just to click stop and save to yes. Okay, and then go to the edit geometry again. Then you can find compute this all access attribute below. Just click this one. And then again, one more stop to save this job. Yes. Now we can check the attribute table for this cross section. Right click on this cross section and open attribute table. So you can see our developed all the cross sections there. Details. So how about this there? So you can see this one is selected, would be the pink line, and then you can find with our all developed cross sections on here. So again, go up. In this table, you can find the lever stations first. So you can find so this is based on our developed the lever system. So this would 5 would be upper Wabash River, and this would be the Tippecanoe River case. And then since this the river is linked from the very upper point to low point, there you can find the continuous, not only here the Tippecanoe, but continuous the stations with the upper and lower Wabash River. And then you can also find the lengths of leftover bank and channel lengths, as well as the lengths of right over bank on here. This is also shows the left and right bank stations. This would be the similar number with this river station number. Okay. So the other things you don't need to consider at this point. So we checked our developed the cross sections. So we can close this one and just save this RAS map for all the jobs. Okay, and then just go back to the main HEC-RAS platform to close this RAS map. In this point, we need to check our directory folder. Last time we developed these three files, and then there is no difference without this backup folder as well as this kind of backup things. Okay, so we checked all the differences for this directory folder, but we just done for the geometry file things, so not much differences you can find without this backup file. Okay. The last thing I would like to show you would be the geometric data we developed. So go to main platform of HEC-RAS and then click edit menu and this geometric data. So you can find this kind of the new window. Maybe your new window will not present this kind of developed things. So go to file and open geometric data, and then you can find the geometric data we developed. Click OK, and then you may don't need this kind of the background terrain data. So in that case, uncheck this plot terrain data on here. So this would be our developed older HEC-RAS river platform, and then we need to check the cross section. So this would be Tippecanoe very upper cross section, and go to Wabash River and the lower part. So you can find all the developed the cross sections we did. So this is very easily developed with the RAS mapper. This is brand new one from the HEC-RAS version 5.0 things, because they developed the RAS mapper. So with this RAS mapper, you can easily create all the required geometric files. So this ends the HEC-RAS model development part 3 video. This one-dimensional HEC-RAS tutorial will be continued with another series of videos for model simulation and fluid inundation mapping. Thank you for the watching.